Okay, hello guys. So this is actually the third video of the series of JavaScript of functions in JavaScript. So here we're going to be doing the concluding video. So as usual, let's go example 3. Okay, example 3.js. Okay, let's close that. And okay, this is not required. Let me just open this by saying, yeah, okay. So now we're going to go with this concept known as hoisting, right? Hoisting in JavaScript. Now hoisting just allows the function to be used before it is actually declared, or before its declaration, right? So a pretty straightforward example there would be to say console dot log. Okay, now we could log, for example, something like square of 4 here, right? And we just define a function here. Let's say square. Okay, it's going to take in a num or maybe an x. Okay, and yeah, just return the x times the x. Okay, so that's what we mean by hoisting. That means like we can actually use this function, because you know that whenever we try to read a JavaScript file, right, we start from the bottom to the top. So that's why we register the functions and then we are able to use it. But now hoisting makes it such a way that we can actually use this function here before it's being declared, or before its declaration, right? So that's what we mean by hoisting. So if you ever get to hear about hoisting, that's simply what it means. Now we're going to go to the next part, which is all about closures. Okay, now closures, so it's something a little bit and it's a little bit difficult to understand, but I'm going to try my best to break it down. So closure is a function that remembers and can access variables from its outer scope even after the outer function has finished executing, right? Now in simple terms, I'll just say if a closure allows the inner function to remember the variables of the outer function. That's just what it is, right? So we could go here and just define a simple function. Let's say outer func. Okay, and now in this outer func we have let's say outer variable, let's just call it here, say outer. Yeah, we could just go with something outer. And now we're going to define another function, say function inner func. Okay, and now this inner func is going to be this, right? It's going to be console logging the variable of the outer function, and then we return inner func, and then we call inner func. Okay, do we call inner func? No, we actually just return it like that. Okay, and now we can say const closure. We say const closure and we call the outer function, and that, and then in this closure now we execute now the inner function, right? So you see that when I comment this, we don't get any output, simply because when we call this outer function here, it just doesn't do anything. It just returns to us this function. So it just returns to us the inner function, which is this. But now once I do this, once I call the closure and I call this parenthesis here, we get outer, right? Now this is what we call by closure, right? Allowing the inner function to remember the variables of the outer function here. So we are calling this inner function, which is this closure here, and executing it by calling the parenthesis beside it, right? And it's able to remember that this outer variable, right, or the variables in the outer function. That's what we mean by closure. So we're going to go a little bit by complicating it a little bit. So let's say function create multiplier, and this create multiplier is going to accept a multiplier. Okay, and I just noticed I spelled that wrongly. Now multiplier, and then it's just going to return to us a function which accepts a number. Okay, and in this we're just going to return the number multiplied by the multiplier. Okay, the number multiplied by the multiplier. So we can say here, for example, const double was anything, create multiplier, let's say 2. Okay, and now we log, let's log this and say double, and let's pass 5, and you see that wherever we get to do this, so this is also another form of closure, right? So this double is able to remember the value, this multiplier, and then do the multiplication or compute whatsoever is to happen here, right? That's why when we pass in 5 we get 10, and 2 we get 4. So that's another example of closures. So now the other concept we're going to treat, or the last concept we're going to treat, is higher order functions, right? Higher order functions. Now higher order functions is just a function that either takes another function as an argument and then returns another function as an argument. Let me just use the word or, returns a function, or both, right? I know you kind of like understand, but in the first part it wasn't supposed to be an order, it's just supposed to be comma. So it either takes a function as an argument, returns a function, or both, or does both, right? So we're going to take a function here, for example, let's say filter array. Okay, and in this filter array it takes an array, and let's say a callback, right? And in this callback we don't do anything else than just calling the array and just saying filter. Okay, and we pass in this callback. So that is just it, and we can then call our console.log. Okay, like this. So we can just say const numbers, and then we filter and we try to get the numbers that are even, right? So we see here we just have 2, 4, and 6, which are the even numbers found here. So this is what we mean by higher order function. So it takes in a function, right? It takes in an argument, and then return both, return to us the value, right? Or you can take both of them, or you can as well return to us a function. So that's that. And now we are going to try something here, right? We have seen how we can use closure, we have seen how we can use higher order functions. Okay, now we're just going to have one simple example here which combine these two concepts, and what we're going to try to do is memoization. That's using closure to cache the results of a function, right? The cache the results of whatsoever we're doing, and by so doing we also improve performance, right? So in that function, or we're going to say function memoize. Okay, I hope I memoize. I think it's spelled like this. Okay, now in this memoize is going to take in a function, right? And we can say const, let's call for example cache. Okay, and in this cache we're just going to return a function. I think I made an error here. Const, okay, remember we've seen the use of the args, right? So we can say const key, no, const key, and we're going to say JSON dot stringify. Okay, and what we're stringifying here is the arguments, or the infinite arguments that we're getting, right? We're stringifying them, and then we say if. Now in this next part, we're going to try to check if the cache already has this value, right? If the cache already has, if the cache doesn't have the value, then we're going to add it to the cache. If it has it already, then we'll just return it. So this is what we're trying to do here. So we say, for example, if the cache doesn't have this value, right, or if this value isn't present in the cache, then we're going to cache it, right? So we're going to say cache, and we're going to say fn, okay, calling the function with the number of args that's getting. So else, right, else we just return the cache. Not even an else, like if it's not there, if we cache it, if it's not present, we cache it, and then we return, right, return with it. So and then we're going to now call here, we're not going to have something like some sort of slow function that takes some time, right? Because that's all about what we try to do with memoization, if that's kind of like how I can pronounce it. So we can say a slow function, slow func, okay, and it's going to be an arrow function. Should we go with an arrow function? Yeah, I think we can do so. Okay, so it's going to be an arrow function, and then we're going to say console dot log calculating slow function for that number, and then what we're just going to return, for example, is the number times 2. Right, so here we're just returning anything. It necessarily doesn't have to be something, well, it could still be num times num, just anything, right? But that's just kind of like going to take some time to calculate, right? So we're just doing something like this, nothing really fancy. So we can say now const memoized function. Should we call it memoized? Yeah, let's call it memoized slow function. Okay, and we call the memoized, then we pass in this function, we pass this function now to it, right? We pass the function to it, and inside the slow function we still need to pass in a number, or yeah, we still need to pass in a number, right? That's what we define here for the slow function. That's what we define here as a params. So we're going to say log, we're going to log and call the memoized slow function, and call, for example, here 5, okay, and maybe in another case too we can say 10, which gives us 20 and all of that. So basically this is what happens, right? And you see that if we duplicate this and call again, if we call again 5, we still have 10, right? We still have 10 simply because this is already present in the, it's already present. Let me just remove this. Okay, so we get a 5 here because this is already present in the cache, right? It's already present in the cache, so that's why when we're calling it the second time, we get only the output 10 from the cache and nothing else, right? So if I delete it, if I try to comment that, comment this, so let me just duplicate this. Let's say for the case, for the scenario of, let's say for example 8, right? We get 8 and we say calculating slow function for 8, and if we get to duplicate this and call 8, then we get now 16. That's our return value. Now we could still try to see this in the terminal, okay, and let me try to clear that and say node example, let's say 3.js. Okay, now we see here calculating for 8 and then we get 16 and then we get 16. Now we don't see this calculating for 8 repeated again, simply because that's like caching, right? There is no need to display twice, right? Because if the value is present, then just return to us the value. If the value isn't present, then it's just going to log this calculating slow function for 8 and then return the values to us. So thank you guys for watching. I hope you grabbed it, and if you have any other issues, you can drop them in the comment and I'm gonna reply or get back to you. Thank you.